Okay. Thank you everyone for being here. We are here within the session of the Research and Innovation Days that has been organized by the Research Tactic organizing team. And we are here with this, I would say, relevant interview on the European Innovation Council Pathfinder with our Yordanis Artimanoglu, which is the appointed European Innovation Council Program Manager for the session Biotech and Health. And thank you, Yordanis, for being here with us. I would like to kindly ask you if you would like to introduce yourself a bit, to explain about your background experience and why you have been appointed for such a demanding role.
Thank you for having me. I started my career as a researcher in genetics and cancer research. I started in 2003, and then I moved to New York. I am, by training, I'm a medical molecular geneticist, which I did this training at Cornell, New York, after I completed my PhD in Europe, and ran a career there as a researcher and chief of cancer genetic research. Then I did 1 year international business program, having my mind when I came back after I completed my career as a researcher in the States. This training program got me into biotechnology because I wanted to have one foot in academia and one foot in industry. And after that, I moved to management positions in Europe, being the chief executive officer of one biocluster in Denmark and one innovation zone in Greece. In the last years, I have been working partially as an advisor to genetic, genomic companies and as EIC coach. I think this rather unusual career is what gave me these different perspectives from having been a researcher, having been in charge of research, heading research in New York, and then senior manager position in the biotech cluster environment and innovation environment. Like wearing 3 different hats. I think that really empowered me with having views from different angles and different aspects of the academic and innovation environment communities, and that was I think what played a role in my selection.
Thank you. Actually, you have said several different relevant items of relevant keywords of the European Innovation Council. Would you like maybe to express why you think that the European Innovation Council is unique, and why you think that also the EIC program manager is a relevant role for make the European Innovation Council unique?
So that's a very valid question. I think the program manager with this relatively new, in a way, position, somebody who, of course, there's some experience in the States from institutions like DARPA and RFI, but the program manager in the very environment is something new, something different. And in my understanding, and I believe in the understanding of those people that are involved with the EIC, has to have different kinds of experience. As you pointed out correctly, for instance, with pure academic experience, it won't be a very good fit. You need to have, of course, a research background, an academic background, because you are working in a thematic sector, and you need to know the sector quite well. You need to have senior management experience, because you will manage not only portfolio, you will manage in the end, indirectly, you will advise companies, so you have to manage the way advise them on the strategy and understand how they could be more successful, which is like sitting on their board as a non-executive board member for some time and interacting with them. So you need to have research experience, management experience, innovation experience. All these are ingredients. You need, I mean, the recipe is to be successful has to have experience, proven experience from all these different areas. And that was not the norm in Europe. I mean, you could find more people with my background in the States, but not in Europe, because it's rare that you leave one career for another career and then for another career. And I had to do that at least 3 or 4 times. Not just changing countries, but also changing objectives.
So do you think that? Thank you. Do you think that this is actually the very uniqueness of this new European Innovation Council, also a governance mechanism, I would say, in a way?
That's a very good question. You could say that. I think the selection of the program managers was understood as such. I think it was not fully understood from day one, but progressively, and I'm experiencing now, although I'm still a newcomer here, but I have been meeting very open-minded people, and from the beginning, what struck me is that it was really so rare that people that here EIC, the management, wants co-creation. Co-creation is not an easy thing. From the beginning, it's not only the program manager that will set or will discover the technological directions and the technological vision for EIC. It's in a way it will also discover his role, his or her role, and that's what makes it very challenging, but also very interesting and potentially very impactful. Of course, you need quite the support to do that. You have all the challenges of the European environment, but this environment is not academia, is not, they have the structures and all, there are different small or big obstacles that you have to take care of, you have to tackle, but the reality is that people like us who come from different areas, senior people from outside EC, getting into EC and bringing this new flavor, this new understanding of things, and they need to, on one hand, to pretty much rely on good science, at the same time on new innovative ways of doing something. This is an interesting match, and you could say it's kind of unique for a European institution, to my knowledge.
Thank you. Thank you so much for your time. I wanted to ask you also one important thing, because you have started to say some relevant issues regarding the management of the research and management of innovation. What do you think, which do you think is the relationship between them? Of course, in your perspective of an EIC program manager, between innovation management and research management. And also, actually, I would like to ask you, which is the acceptance of failure in research within the European Innovation Council Pathfinder, which is actually supporting collaborative research, high-risk research, high-gain research. Thank you.
Yes. I will answer your question directly on the Pathfinder, on the also former FET, and because Pathfinder is broader than FET. Pathfinder will get breakthrough process from different sources, including FET. It's what we see in America: no pain, no gain here. I mean, you have to have a high-risk projects, that's for sure. And if you don't dare to go for really high-risk projects, your chances to get to a breakthrough, a very impactful breakthrough with high potential of commercialization, high potential of, creating new knowledge, new economy that transforms to new values. Before money is the values. Because you can make money either by developing a product or a service, but you can also make money by creating a very strong IP portfolio, which is another way for the SMEs. So the reality is that from all this cycle of development, you can find people that can help you in different steps of this chain of development. What you cannot change is the science. If the science is not good, this is not correctable. If the science is not really a breakthrough science, then there is no way you can fix that. You can fix several things along the way of developing something. You can find very good people advice on regulatory issues, on business development issues, to link the company, to link the startup with others, or to advise even at the stage of where you are validating your technology. But there are technologies out there that you could create joint ventures with other people about. All these things, I believe, theoretically can be corrected. So another good thing for the program managers is that they have been selected because of the depth knowledge in one area, in one broader sector. And that was missing. And now we have that. The program managers are people to work, allow me to repeat that, on one thematic sector or subsectors, because outside that, you don't have the expertise. This general belief that you can do innovation in general, or you can apply, for instance, artificial intelligence in general, these are not very well justified, because from one sector to the other, the data, they don't speak to each other. The experiences are different in development. Even AI is a platform that can be used with different data, so it's just a tool to apply on one sector. The time length and what you need to develop a good research project to innovation, because you asked about this relationship between the two, differs from sector to sector. So we got to start thinking along the line that maybe innovation development in general is not the most appropriate term, but innovation in general within a broad thematic field. And that is my vision, and that is what EIC has been doing by selecting people with specific expertise. And what is needed is these people, these program managers, to be empowered with a support team that is not focusing, won't be focusing on administration, but will be focusing on innovation intelligence. This is key. So, innovation intelligence is what I'm strongly supporting and recommending for the future fully fledged EIC. And the reason is this is what's going to make the difference. This is going to be the base of the uniqueness of EIC.
This is actually really interesting that you are going to be supported, because actually you will have an eye with different I would say, chapter organizations, basers, different, all the actors, relevant actors in Europe, within the specific sector is located biotech, but of course there will be other EIC program managers and program manager appointed that will have an eye on other relevant sectors, and it is actually quite good that you are going to have a comprehensive team around you that is going to support these ambitious aims. So this is actually the next question that I have for you. Which are your personal expectations for this role?
That's a very good question. Let me just answer your previous question. There are the potential is high here at EIC, but there are also challenges. I want to be frank with you. The challenge is that although the understanding is there and we are in, and this is very nice, the system is not really fully ready for us. Hopefully, that is very well in the pilot phase. Hopefully, and I'm confident that in the fully fledged phase of EIC starting next year, these things will be resolved, and these things will be, for instance, we need to have a strong support team. We don't have that now. Hopefully we'll get that. Also, the understanding within EIC is growing towards the thematic development. It was not there per se from the very first beginning. And each one of us, with his personal experience, of course, trying to bring inside his vision. And his vision, my personal expectation is, as I said, in my field, health and biotechnology, which is a broad field, to create what is missing now from a European institution, to create an internal capacity, innovation intelligence capacity, to be able to make assessments on the different projects under Pathfinder and have an opinion, which is going to be our scientific opinion on the innovation, on the breakthrough. Of course, we will then consult with other experts, but we will have my personal vision is that to have internally the capability, the skills to make a judgment, to make a real assessment about project X, project Y, startup X, startup Y. This is for me was the driving force, if you want, and part of my vision when I decided to join EIC. How do you do that? You do that by, you do different things. For instance, the PM is somebody who follows the current global trends all the time in his field, so he has to be really informed, meaning lots of reading of what industry does and what the good universities do in research-wise. In the end, you use all that for the benefit of the elite project and the elite rising startups that you have in your what is called portfolio. So you create a league of elite projects and you follow them closely. You and you're supporting, and with externals sometimes. The goal, what is my expectation, is not what is usually heard is to create another Google or another Microsoft. That is something nice to have. If it happens, it will happen. The goal is, by closely monitoring and following a group of those projects, is that you do specific things, specific moves, but they create an added value for them, and they enhance and they augment their valuation. One thing. Another thing is that through the partnerships that you can recommend to them, or you can discuss with them, there is a possibility to because you have in your radar, you have different companies and different projects. You know something that they don't know. Who else is doing what? So you inform them about that, and you advise them that, for instance, about competition in one case, or about the potential synergy in another case. And that potential synergy can create more assets in the new legal entity or in the new partnership. And having more assets, your chances to be funded by private investors are higher, getting higher. Also, the chances to in a more rapid manner, reach your goal, which is a new product, they also get enhanced. So all these moves and all this, strategic intervention in a community, in a selected elite of companies and projects, can pay off by more private money put in these companies and these projects, but also by faster getting to the point of the commercialization. This is the desirable that you want to commercialize what you have developed. That financially means high valuation. So you may be following 20 companies and 20 projects, and 2 years down the road, their valuation, their technology valuation is 5-fold higher than 2 years before. That is a personal goal. Another personal goal is, have you been a catalyst of 10 new licensing deals of technology platforms? That can be translated to money. These things can be measured. These things are what is called KPIs. And this is the goal of the program manager, in my understanding, to increase the value of his or her portfolio in a measurable manner.
Thank you, Yosan. Actually, I was really listening to you with attention, because before you were mentioning, and I think that with this answer, you had also give us more information about what do you think that is the EIC Pathfinder, that should be the EIC Pathfinder in a fully fledged European Innovation Council. Do you think that besides what you have told to us right now, because you give us a really comprehensive vision of your vision of the EIC Pathfinder, do you think that before you were saying that the European Innovation Council Pathfinder is not only set is not only what was said. In one sentence, what do you think that is going to be also embraced in fully fledged EIC Pathfinder that was not in that?
In my understanding, program manager wants to create, as I said, a portfolio of elite startups and elite projects. So it's part of the role of the program manager to look where to find all those breakthrough research projects. And these projects can be found in other programs or other European institutions that they fund good research, and there are many, Joint Research Center, European Research Council, or even EIT, and there are many of them. So, we're not going to be restricted to those that have been funded by EIC only or by FED. We would like to broaden our search for good projects, because at the end of the day, the goal is to have the most promising projects. So that's why the work here is a little bit demanding. How do you get there, and how do you find all those projects? And we are starting with that. It's we're only two now, but in our field, approaching and thinking how should we get to those projects, and you can't do that only by doing searches and with keywords. This is very understandable, but you have to have, as I said, very good knowledge of what is happening in the industry right now, what are the emerging technologies, and make some really be able to understand and in a way at the end is like betting and say, I believe that this specific area is hot right now for the of course, providing very good scientific arguments and real needs, unmet needs, and you go by that. So you have to look into projects that are being developed, funded by other institutions, but also, I would say, and we have to really be bold here and there, try to find other projects that have been funded or they have not been funded by private sources, and they're really promising. So we want to have in our radar within a specific sector all possible projects, research projects with high potential in new knowledge, because in the end it's knowledge-based economy. It's knowledge-based economy in our field. This is what happened right about why we want to go broader than that. Yeah.
Okay, so actually, when you are going to select the research items that are going to be under the portfolio, we have listened several times now the concept of research portfolio. So actually, you are going to check within research projects funded under the EIC, but also under Horizon 2020 level, but also at the national level.
This is great. This is a great question, and this is in the end. I hope that we will also create our intelligence here. This is what the big corporations do. For me, one model that I don't know if some people sound strange. EIC in the end, in the selection, it will in a way behave the same way a big corporation does. You have a huge R&D department, and the R&D department has, because of all these operations, they are already positioned in non-thematic areas. You have the head of R&D. The head of R&D could be the program manager, who works with teams, analyzing the data and the information that he gets from public sources and from proprietary sources. Mm-hmm. And you have to have subscriptions, and you have to have competitive analysis, and you have all these tools. Nobody will tell you exactly how they do it, because that's their intelligence.
Of course.
For me, it's a personal vision to create the intelligence within EIC, and of course we will reveal all how we do it. It will be after a few years we will know if what we have done has paid off or not. Because we are catalysts and we want to create value at with economic impact, but in some cases with social impact as well. So it's a little bit different than sitting in wearing the suit of the head of R&D. But there are also lots of similarities: how you work, how you gather your proprietary information, how you make your judgment about your assessment about something. Who decides in the end? When it says that we need to focus on that and that and that because of, and also about flexibility. If you follow what is happening in the world, it is not uncommon that some new technologies have come up, and probably something that you have invested in, and invested here is not only money, it's support. You have to decide that there are better solutions. It's a go, no go process. That's why I said it resembles the corporation. The corporation, the management of the R&D does go, no go process all the time. We continue that project, we enhance our efforts, or we terminate that project. We should be doing the same.
Okay. Thank you, Giordano, for all your answers. I have a last question for you regarding the future statistic. You know that the future statistic is the sort of celebration of the European Innovation Council Pathfinder results. So who should celebrate for you and why and what, actually?
Let's say who is directly affected by that? First of all, I believe directly affected by that there are different stakeholders. University and research centers, those that are really on the forefront, and they have in their agenda, they are serious about doing radical, innovative frontline research. They are investing in this research. They will benefit because FET is the funding arm of this type of research. Most of the universities, they don't want to rely on this radical research. They do more business as usual, more straightforward research because they want, of course, to have publications, citations. So, among the stakeholders, I believe people to celebrate are these leading universities and research centers. Researchers, I would say even more, that their strategy is pretty much based on bringing something really exciting, something new. And they know that 95 times out of 100, these projects go down the drain. But they do what they do for the 5%. So FET is, as I said, research institutes, they should celebrate because FET exists. In a way, they owe to FET their choice, their strategic choice. Because without the FET funding, they should have turned elsewhere. And I'm not sure how many funding agencies or funding opportunities or investors are out there that they will select to go to high-risk projects.
So at national level, so of course.
Number one, people to celebrate and acknowledge FET's existence. The FET program are, I believe, as I said, these research and universities. Then is the industry part that also, again, it's not all industry, most of the enterprise of the United, there is a lot of industry in generics, non-innovative drugs. They won't care at all about it. But the companies that are developing innovative drugs, and they know that they cannot really create revenues from either doing a small improvement in one drug, or just repurposing a drug, or doing all these modifications to bring a new drug to the market. There are some companies that they go all the way from scratch, finding a new target, a new hit, and do the development of a new drug, a new diagnostic. Those leading companies, they should be thankful in a way to funding agencies that they support breakthrough research in the very, very early stage of development, where they are not there. So FET is one of the agencies, one of the is a program that supports that. So for those companies, SET is a good thing because it solves that problem. It allows some breakthrough research to really get to the next level from A to B, to be validated the technology, to be optimized the technology, and they will get into the picture much later. So they should appreciate that there are entities like SET, and they make it happen for them. And this is number 2 stakeholder, I would say. Small portion of the industry, small or big, I'm not sure right now, probably small, but the portion of the industry that focuses strategically in their pipeline on innovative drugs, diagnostics, looking for my field, the same apply in another type of industry, in defense, for instance, in innovative new technologies applicable to defense.
Thank you. Thank you so much, Jordan, for your answers to our questions. I hope that you find them also interesting from their side, from your point of view, also for thinking about the future, what you expect to do in your current role. And I would like also to thank you for your passion and for your collaboration to this celebration of the EIC Pathfinder results. And thank you so much, and have a nice day.
Likewise, thank you for the opportunity to discuss with you my views and my new role.
Thank you. Thank you. Bye.
Bye-bye.
Imagine we could shrink a microscope down to the size of a computer chip and transform it into our own personal laboratory device. We could then put it into our pocket and take it everywhere, also outside the labs. This sounds like science fiction, doesn't it? But we are closer to it than you think. The European Commission is funding a research project that will develop the first optical microscope that will fit on a chip. It will have LED light sources that are 1,000 times smaller than the diameter of a human hair. Yes, the smallest nano-LED array in the world with individual pixel control capability is currently being developed in the labs which work together in an international research project called ChipScope. But how will the new tiny microscope work? You all know shadow images. Light goes through an object, for example the hand here, or not. We use exactly this principle for our tiny microscope. Extremely small objects such as viruses, DNA or living cells are illuminated by very tiny LEDs. In this way, images are not limited by the diffraction of light and we achieve what is called super resolution. Normally you would use a large microscope for that, but we are working in the nanoscale, where, you remember, the dimensions are 1,000 times smaller than the diameter of a hair. The ChipScope microscope will produce a shadow image of these extremely small objects. This image is then sent to a computer, so you can see it. Sounds simple, but it is a real challenge, and it needs the collaboration of European universities specialized in this field. And now let's dream a bit, and just imagine what would happen if a whole microscope fits into a mobile phone. The 8 universities, research institutes and companies working together in the ChipScope project are in Spain, Germany, Austria, Italy and Switzerland. ChipScope, a completely new and extremely small optical microscope.
first of all, thank you for agreeing to answer some questions about this Icarus software.
Thank you for inviting me, Nicola.
Okay, so I think we should start with the most fundamental question. This is, can you describe Icarus software in simple terms?
Well, basically, it is a mathematical tool to describe the thermodynamics of polycrystalline materials. I know that thermodynamics is not a simple word, so let me say that basically the tool is able to describe the preferred structure of this material depending on the composition and the temperature. Why is it important to know the preferred structure of the material? Because properties strongly depend on the structure. And this is in particular is very important for the case of nanocrystalline materials, because we know that the properties of this material are strongly dependent on the grain boundaries, which are very difficult to take into account. So the most innovative features of this software is that to take into account the grain boundary, to describe that, and then to relate this the role of the grain boundary to the, let me say, the properties of the material. Mm-hmm. So this is mostly the fundamental features of this software.
Okay, thank you very much for using very simple terms. I know it's not easy to do that.
Yeah, I try to do my best.
No, you've done it. Okay, so what is it innovative about this Icarus software? What's its added value to the current state of the art?
Yeah, basically, as I said before, the most important feature is grain boundary description. I mean mathematical description, obviously, because we are talking about software. And the actual commercial software don't take into account this feature. And this could be a problem in the case you want to describe it, to model nanostructured materials, because it is well known that grain boundaries and then surface feature play a very big role on determining the mechanical, physical, and chemical properties of nanocrystalline alloys. So this is, this is the most advantage of this software with respect to the existing ones.
Mm-hmm. Okay, we've been talking about the advantages. Now let's have a look at the drawbacks. So, from the point of view of the potential users, what problems can you foresee using the software?
The main problem would be the usual problem of mathematical models, because mathematical models need data, need parameters, need databases. And for some parameters, the state of the art is not sufficiently accurate to provide some parameter. So this is the drawback. I'm confident that in the future, the scientific research will provide a database with an increasing number of parameters and an increasing systems.
Okay, so you've talked about the future. Let's focus on the future. How close are we to a full predictive tool in this domain that will make life easier for engineers in order to simulate or to know the properties of this kind of nanosystems?
Well, let me say that this is actually the first attempt to describe in such detail and general features this scientific problem. So obviously there is a lot of room for improvement, in particular from the description of specific feature of the grain boundaries, and there is also a lot of room for the development of the suitable tools to estimate the parameters our model needs. So, for instance, experimental data for an high number of systems are obviously welcome. That could be very useful to make model prediction more precise and more reliable, for sure.
So we have to wait for experimental results.
Yeah, absolutely, absolutely. Mathematical model is never developed to substitute experimental activity, but just to make some synergy. So to make knowledge improvements between the sharing information between models and experimental data. So.
Okay. Well, thank you very much for your nice explanation of Icarus software.
Thank you to you, Nicola.
Will electromagnetism technology last forever? Electrons involved in electronic applications have some limitations. There's a speed limit, and they also heat up components. At Phenomen, we are developing a radically new technology based on phonons that will mean a breakthrough in the fields of informatics, electronics, and telecommunications. An interdisciplinary team, including 3 research institutes, 3 universities, and an industrial partner, is working to lay the foundations of a new information technology. Phenomen is a future and emerging technologies open project designed to harness the potential of combined phononics, photonics, and radio frequency. To generate electronic signals by converting light into vibrations and vice versa as information carriers on chips. Ideas like this can change the world we live in. Phenomen, new information technology.
The human body is constantly affected by physical forces. When you cut yourself, cells in the surrounding tissue apply forces to heal the damaged area. In the same way, cancer cells apply forces to spread to other parts of the body. To understand these mechanical forces, we need to look at them at many different scales, from molecules to organs, and all the way up to entire organisms. Understanding how these forces work would allow us to unlock new avenues in cancer research, regenerative medicine, and the design of biomaterials to be implanted in the body. At the nanometer level, which is the level of molecules, cells stick to their surrounding extracellular matrix and to other cells using integrins and cadherins. Forces applied to these molecular links change their properties, determining how cells behave, and sometimes activating the expression of genes. Some of these, like the ones triggered by the oncogene YAP, play a role in cancer. At the micrometer scale, cells work together to respond to their environment. They combine biochemical mechanisms, such as signaling, with a biophysical response to react to mechanical forces, such as when there's an injury. Similarly, at the millimeter level, the tissue level, the collective actions and interactions among large groups of cells define the architecture and function of the tissue, depending on where it is in the body. And at the meter scale, the scale of entire organisms, all interactions at the molecular, cellular, and tissue level integrate to result in organs and ultimately functional organisms. We know that forces are involved at all the different scales, but how exactly do they contribute to tissue and organ behavior? To find out, the Mechanocontrol project will put together a toolkit to uncover cells' responses to forces at every scale. Like a well-stocked toolbox, the kit will include different tools in which the 7 Mechanocontrol partners are experts. These will range from single-molecule nanotechnology at the smallest scale to organoids and animal models at the organism scale. It's the first time that expertise in such a broad range of technologies will be put together and applied to all the different scales at which biological functions occur. In particular, Mechanocontrol will apply its toolkit to breast cancer. If the partners can understand cancer biomechanics from the single molecule to the whole organ scale, they'll be able to control mechanical forces to restore healthy cell behavior and inhibit tumor progression. Ultimately, it's hoped that the project will lead to the development of breast cancer treatments based on the new discoveries. The principles revealed by the project's toolkit will also apply to many other biological processes and diseases.
Hello and welcome to this Future Tech Week session on advanced laser processing strategies. My name is Sarah Keane, and I, along with my colleague Eric Prem, represent OITEMA, a member of the FETFX consortium. This roundtable will discuss the FET-funded projects Lena Biofluid and the upcoming project Laser Implant, both of which look at using lasers to change the properties of surfaces. We are joined by Dr. Emmanuel Stratakis, Research Director for the Institute of Electronic Structure and Lasers at the Foundation for Research and Technology at Hellas and the University of Crete, as well as Project Coordinator of the FET Open projects, Lena Biofluid and Lab Bionics. And we are also joined by Professor Dr. Johannes Heitz, who leads the Applied Physics Research Group at Johannes Kepler University in Linz, Austria. Dr. Heitz is the coordinator of the upcoming FET Proactive project, Laser Implant. Welcome to you both, and thank you for joining us. We'll start with Dr. Stratakis. Why don't we start by having you tell us a little bit about your work in the Lena Biofluid project. Please describe how you came into the brilliant idea to analyze the integument of animals.
Yes, actually, this was a very nice project, and we really enjoyed it. So the story starts when Johannes Heitz, our colleague that is currently in the panel, he started some discussions with people that biophysicists in his university, in Johannes Kepler University in Austria, on how we can actually mimic the structures of the integument of the animals, of this kind of lizards and bark bugs that this biologist studied very well, but they have, let's say, studied that they exhibit very nice functionalities on their surface. How to mimic this kind of functionality in artificial surfaces. So he started this discussion, and then we entered in this discussion. We had, let's say, some history on how to mimic the surfaces using the laser structuring. So use a laser beam to sculpture the surface in order to go down to mimic these extraordinary shapes that the integument of animals exhibit. So we have started this discussion. We have applied for this project, and actually it was a quite successful project. I can recall that at that time the percentage of the rate, let's say, of success was about 2%, close to about 1.7%. So it was really successful project. So the main idea of the project is to mimic these structures in order to manipulate or to control the fluid transport in artificial materials. So the nature so does the way we have studied this way, and we have managed to mimic in order to produce artificial materials with these extraordinary microfluidic properties.
Great. So please describe a little bit about the Lena Biofluid project in terms of technological and scientific impact.
Yes, Lena Biofluid actually, through this process of mimicking nature's, let's say, strategy to manipulate liquids, has managed actually to provide artificial materials that show exceptional friction reduction. So imagine that we have a slide bearing in a machine. Then if you treat this slide bearing with a laser processing that we have identified through Lena Biofluid, then this piece of machine shows exceptionally reduced friction. So this means actually that there is a reduction in the energy consumption, and in the long term, a reduction in CO2 emissions. So this would have a great impact actually in the current technology of machines. I mentioned one of the examples, but there are plenty of examples for example, mechanical components in microfluidics or in micropumps, that if you treat the main part with this surface finishing, the surface processing, then this will show exceptionally reduced friction. So this is very important, because if you imagine friction is one of the biggest problems of the most energy consuming issues in the modern technology. So if we reduce this friction, we reduce the energy consumption and then the CO2 emissions. So this has a great impact in currently.
Great.
Great. Sarah, can I step in with a question?
Of course.
Emmanuel, that's a fascinating project. I was wondering, I mean, this is an interesting combination of let's say a science project, which is the bio part, then the physics part, which is obviously the laser and the surface physics, but then also a technological one. What came first, and can you describe a little bit? I assume you also in the project had to look into some inspiration from science. How did you do that? How did that work?
Yes, everything has, I mean, this is mostly a basic science, has started from the basic science problems. So the biologists have, let's say, have the very fascinating problem of to understand how nature is working and how through the evolution this functionalities has been developed by nature. So this is the one part. The second part is how to fundamentally study the laser material interaction in order to control the shape on a material surface, the geometry, the size, the periodicity. So it's a fundamental problem of laser material interaction that can give you this capability to control, to precisely control the shape. So this combination, so this is an interdisciplinary, let's say, interaction, and that's the highly disruptive, let's say, idea. If you combine this expertise, these two fundamental sciences, then you end up with a great technological, let's say, invention. And this was actually the idea that that Lina Biofluid entered into the table. So that's, I mean, it has all started from basic science, and then this evolved into technological, let's say, invention.
Great. So Professor Dr. Heitz, why don't you tell us a little bit about the upcoming laser implant project? What are going to be the aims and expected outcomes?
Maybe I go here a little bit in history.
Sure.
So the Lina Biofluid project, we had as animal models lizards. This was a little bit older, and a new idea which started in principle with Lina Biofluid was bark bugs. So bark bugs are bugs, really bugs is some kind of insect which live on the bark of trees, and they have the possibility to guide fluid quite rapidly, and we thought this could be a good starting point for the reduction of wear and friction due to the guidance of oil. Mm-hmm. And we, as Emmanuel described, we succeeded to do it. And we could indeed measure reduced friction with contact between laser processed surface, which had similar features like you find on the bug, and steel counterpart. And the material which worked best at this time was a titanium alloy, which was processed by the people, the project partners in Berlin. And parallel to it, we had some activities where we tried to reduce the adhesion of cells, biological cells, on implant surfaces. And the background was that we had a cooperation, still have a cooperation with people from our cardiology department in our university hospital. And they implant pacemakers into the heart, and they have to be removed after some years because of battery lifetime. And they should not be totally overgrown by tissue. And the idea was whether you can change the surface properties that they don't get overgrown. Mm-hmm. And it was the same material as we had for the wear reduction. And I thought, let's take the samples from Berlin and let's test how the cell react on them. And indeed we found that also the cell adhesion was reduced at exactly the same material. So we in principle developed the material for wear reduction, but we found out that at the same surfaces we see also cell reduction and cell growth reduction. And based on this, we started an innovation launchpad project with a smaller budget, with only a few partners, with partners from Berlin and the hospital. And we tried to find potential applications for this idea. And we succeeded to find some companies who would be interested to use it and to test our samples. And the most easy and the most promising thing was bone screws. So with bone screws, it's the same material, also titanium alloy, and they are screwed into bone. And also most of this, and nowadays most fractures in bones are treated with these screws, and also these screws have to be removed. So typically, maybe not the screws themselves, but they fix plates onto the bones, and the plates have to be removed. And to remove the plates, you have to remove also the screws. And if you wait too long, and this is half a year or something, then it gets difficult, and the screws can break, and then the minimal invasive treatment, which is with these bone screws and plates, becomes not minimal invasive anymore. You have really then to cut out the screws. And so we came to this point that it would be also interesting to have bone screws which have these properties. Mm-hmm. And during this launchpad process and a little bit later, we then found out that it is possible to get cell reduction also on screws. And it was a little bit more difficult because it's different cells which are of interest. So typically the pacemakers, the cells of interest were fibroblasts. Fibroblasts are cells of the connective tissue. They produce a lot of collagen. They make scar tissue, for instance. And for the screws, it would be osteoblasts. These are cells which are built up bones. And they were more difficult. So they liked the surfaces, rough surfaces more because they live on rough surfaces in the bone. But also here we found parameters that we can suppress the cell growth on the screws. And then we decided, and we were offered, of course, and supported by the European Commission, and they announced that there is a new kind of projects, this Pathfinder projects, supported by the, I think, European Innovation Council, and which exactly has the idea to bring out results of FET projects to a higher technology readiness level. And we thought about it, and we talked with the people from the company, with the bone screw company, and we also came in contact with other people working on dental implants where you have similar things. Maybe there you would like to have a better integration into the bone, but it could also, this effect can be reached by laser processing with a little bit other parameters. And this was a French group, and we put them all together and then applied for the laser implant project and were successful. And we will start in 1st of January.
Great. So as far as how you would describe the innovation potential, potentially resulting products or services?
Yeah, so for us, it's clear, it's implants. So dental implants or bone screws. Of course, it could then also, maybe we could come back to the original idea again to have smart, for instance, pacemakers for the heart. But this is more complex. So the whole system is much more complex, and we also somehow with the surface treatment, we intervene somehow with the function of the implant. So we decided to go to the simpler systems first, which are mainly passive. But this could be extended if we are successful.
Maybe can I ask a follow-up question also to Emmanuel? I mean, you mentioned friction and bearings as potential targets. I guess, I mean, this is a huge, as you said, this is a huge application area. I mean, is this something that you were targeting at the start of the project, or is this something also that developed a bit more during the project?
This was the main target of the project.
Right.
So we have promised actually a very high percentage of friction reduction during the writing of the project. And unexpectedly, we didn't expect that we will manage to reach such a high friction reduction through this process.
Right. This is actually, this brings me to a follow-up question. I mean, the EIC Pathfinder and previously the FET projects, they are a little bit special in that you have, as you called it, basic research, or let's say a more long-term research perspective, but you do have a technological objective in mind. So some researchers, or at least some research administrators, think there is a tension between these two aims. But we have now also talked to some other researchers who say this is actually not a tension at all. This is more kind of aligning research. How do you see that? Is this, how do you perceive these, let's say, this double challenge of doing very good long-term research, but also having a technological objective?
Yeah. Let me first say that everything is started from the basic research. Nothing can be ordered, and anybody that says that we today will identify, let's say, will invent, for example, the laser. This is, I mean, this is not, let's say, a good, the correct, let's say, thought of research. So everything is started from curiosity-driven research, and then you build up on this research when this kind of research is mature enough in order to produce these technological advancements. So behind this technological objective we had in linear biofluid were many years of basic research on laser material interaction, as I mentioned, and also on the biophysical models that we had in mind. So I think that the main, let's say, there is no a dilemma to my perception. We have to invest on basic research, and then through this process, we'll end up with highly technologically important inventions. Otherwise, we will be will make, let's say, an incremental, let's say, incremental technological inventions. The big inventions start from investing in basic research.
Right. Maybe Professor Heitz, would you like to?
Maybe I can also comment a little bit on this. Also, let's say with the example of the linear biofluid. So actually, we as people at the university, we go for both. For us, of course, also the basic research results are very important for ourselves, for our careers, for the careers of our PhD students and of our postdocs, which are working in the projects. But we had from the biology, which came mainly from the University in Aachen, and my colleague Werner Baumgartner, who was former professor in Aachen and now changed here to the JKU again, to the Johannes Kepler University in Linz again. He brought up this idea as an expertise in biology. And they have made quite good things over years, and they have especially started the water transport of desert lizards which on their skin transport the water to the mouth. And they have made some theories, and they thought they understand it. And they also worked already with laser processing to mimic these things. And so we had then the new idea with these bugs, which also have a very specific microstructure for liquid transport. But we were quite confident that from the basic research point, we will be successful, because we have already such a huge experience, and this would probably, if we would probably be able to understand the principles, and probably will be able to mimic the structures. But then we had also in mind for what could this be used. And then we came for wear and friction reduction. And this was not true at all. We had nothing in this direction. And we thought, let's try it. And the people in Berlin had worked a little bit in this direction, but not with the structures. Let's try it. And so this was the risky part, I would say. So the basic research part, yeah, we continued our ongoing quite successful activities. And the risky part was then the application part. And it also came up in the project, as I described, that the applications which we thought at the start was not the only potential usage, but we found other things as well. Emmanuel also will describe, certainly they had quite nice results with anti-reflective surfaces. And so we found other applications as well. And we just went in with one target, but also with open mind for application. I think this is the main point. You have to start from a good base on fundamental science, but you should be open-minded for potential applications. Yeah. And the FET projects give a good base to do this.
Can I come back in the? So Johannes is right. I mean, there is an endless potential of this, let's say, technology that has been developed through basic science in many sectors. For example, we have targeted through linear biofluid friction reduction, but then you can see that, let's say, biological adhesion entered into the game. Also anti-reflection, as Johannes mentioned, we have developed an anti-reflection technology based on the same strategy to mimic the nature's, let's say, strategy on how to produce anti-reflective surfaces, and to push forward many ideas, many other ideas through this process. So it's quite, let's say, fascinating to start from your knowledge and see that there are many windows, many opportunities for technological advances.
You briefly mentioned it already. Maybe I can have a follow-up question here, and this is the nature of the FET program, or the EIC Pathfinder FET, as it's going to be called from now on, which aims for precisely what you have described, long-term research, but with a technological long-term perspective. I mean, what do you think is special or important in this program? What would you say are the aspects that should be maintained in the EIC also in the future? Or maybe we start with you, Emmanuel.
That's a very nice question. It's my favorite. Since, I mean, it is a lot of, we have a lot of experience from this. We have started from FET, of course, the FET Open, but through this, the different, let's say, tools that the European Commission provided us, I can, let's say, I have a very clear, let's say, opinion on what I think that it will improve, what I think that it is very nice that it is present now. So the European Innovation Council, let's say, calls, the current European Innovation Council calls are quite helpful, I can say, for a researcher that would like to push forward a technology. So let me start from linear biofluid again. Then we have these three actually, FET Innovation Launchpad projects out of this project. Labionics, that is targeted to, has targeted to under-reflection technology. The one of the cell-free implant, as I can recall from Johannes and his team, that is targeting biological adhesion. And also there is BioMarble, I cannot recall it very well, but it's an initiative from the European Institute of, the Spanish Institute of Optics, led by Jan Siegen. So, and is targeting actually how to produce improved surface finishing of marbles. So there are three technologies came out of Lina Biofluid. Then Johannes has created, has pushed forward another European Innovation Council tool, that is the FET Proactive tool, and push forward the TRL, the Technology Readiness Level, for his research, for his concept. And we also, through Labionics, pushed forward an anti-reflection technology. We are currently have funded by another tool of European Innovation Council, and this is the EquiFund, that is, let's say, cooperation of the European Investment Bank with the Greek government in order to finance startup spin-off companies that came out, let's say, from this from European Commission competitive calls. And we are very happy that we have initiated the spin-off company named Biomimetic that has just launched, and we have attracted the seed funding of about 900,000 euros. Okay, I wish I was now. Anyway, so this actually completes a circle that has started from a basic research, and then we have exploited all the tools of the European Innovation Council in order to push forward our technology. But there are a lot of, let's say, there is a lot of room for improvement, and I strongly, let's say, support the idea of investing more money following this kind of basic research proposal, like ERC or FET projects. Unfortunately, there are not many tools to fund basic research, but at least those we have to invest to those people that came out of these projects to help them push forward the TRL. Also, I have written this also in a forum of the European Innovation Council. I strongly support mono-beneficiary tools that will provide the researcher that came out of this project to push forward his idea, his patent. So if he has a patent out of these projects, then he can take the resources, he can receive the resources in order to push forward this technology. Because there are some, let's say, difficulties if you would like to have to interact with the current industry. There are IPs, for example. The researchers do not want to share their IPs with industries. So it is sometimes difficult to interact with big industry in order to push forward the technology. So if you are the only beneficiary, then you have all the measures to push forward your idea, to make, let's say, to push forward an SME, or to start an SME, to build your SME, and then to push forward your technology. So this is, to my opinion, the environment that a researcher faces from the writing of the basic idea towards the market.
I don't know, maybe Johannes, would you like to add what your favorite aspects are of the program, and what should be maintained in the EIC programs?
Yes, I also like the ideas that you can really follow up the results from the basic ideas, which are very free, which is also very good. it's thematically open, which I also like very much, because it gives the room for wired ideas, let's say it like this, and which have nevertheless often very good outcomes. Because if you always go on the same path, then maybe you will be very successful on the long run, but some wilder combinations of researches and ideas often give quite interesting results. And to have the possibility to push them further, it's really a good idea. And also what we did now is, also in the laser implant project, we had inclusion of SMEs. We did not found our own SME. Actually, our French partner had SME already, which was a startup from the University for Laser Processing. But to include especially SMEs in this raising of the technology readiness level, I think, is also very important.
Sarah?
Great. Well, I think that about covers our questions. So we would like to say thank you very much to both of you for taking the time to talk to us today, and we wish you all the best with your future research endeavors.
Yeah, thank you from my side. Thank you very much for the discussion.
Thank you also very much. It was a great pleasure, and it is very nice, let's say, initiative to discuss with researchers and people that they strive a lot, let's say, to receive funding, but yes, but at the end of the day, to produce something that it is very useful for Europe, for European citizens.
Yeah, absolutely.
I also thank you very much for the possibility for us to present for broader public our projects and our ideas. And I also hope that this ideas of the strengthening of the innovation in the European funding continues.